Okay, well, we got another minute. I'm going to start class with any questions you might have over the homework. So if there's any problems you want to go over, we can to start. Does anyone have anything they want me to look at? All these conversions, all these word problems, everyone's good with that? Yeah? Yeah? Okay. So I don't need to go over any of this then? There's nothing you want me to do? Crickets. That's all I hear are crickets. Just looking. I was looking. 62? Okay, I was looking at 60. And I was thinking, man, that's really, this problem, I guess, my daughter was running a fever all weekend. And, you know, I looked at a chart just like this on the back of a bottle to figure out what to give her. And I looked at number 60, and they're saying, okay, child's 4 years old, weighs 36 pounds. How many milliliters of medicine will he take per dose? And so I was looking at what that would have required you to do, and it was kind of a pain in the butt to do that problem. So I'm going to start with that, then I'll do 62. So if we have a child that's 36 pounds, we're looking at 1 teaspoon, right? And most of those little measuring cups have teaspoons on them, so it's pretty easy. But if we were trying to convert this to milliliters, which in the medical field, a lot of times, almost all the time, everything is in ml. So how do we go from 1 teaspoon to milliliters? Well, I'm sure in the medical field there's a nice conversion factor that they would give you. But the conversion factors that I have, that I'm going to provide you, don't have that conversion, I believe. I looked at it. I did not see it. So we're trying to go from 1 teaspoon to milliliters. Let's take a look at our conversions. Where the hell are they? There they are. So if I'm trying to go from 1 teaspoon over to something milliliters, like that, then how can I do that here with just this? So the only thing that I see on this chart that has teaspoons is this right here, right? So I can say that 3 teaspoons equals 1. What's the abbreviation for tablespoon? TBS. Is it TBS? TBL? I thought it was TBL. Do we know? No? We don't know? Well, yeah, can we just do TBS? We're all happy? Tablespoons? All right. So we have that. That won't get us to milliliters. So this will take us from teaspoons to tablespoons. So what else would we need to do? Look, I already told you last class, like, yes, you can get on the internet. Yes, you can do that. But the big point here is how do we use conversion factors to go from one thing to the other. So I like the fact that this problem is going to require multiple conversions because I think the idea, the method is more important than anything else. So what's that? I can go from tablespoons to let me see. Tablespoons, right? I can go to cups, right? I know that. So I can go 16 tablespoons equals 1 cup. Okay, I'm trying to get to milliliters. So yeah, the only thing I have in milliliters is ounces. So can I get from cups to ounces? Right here, I can get from cups to ounces. Do y'all see that? So I have 1 cup equals 8 ounces. I'm going to go OZ for ounces. And then finally, 1 ounce equals approximately 29.57353 mLs. Okay? So to get from teaspoons over to milliliters, I've got to go from teaspoons to tablespoons, tablespoons to cups, cups to ounces, ounces to milliliters. All right? So if you're in the medical field, you definitely won't have to do this. You'll have something that goes right from teaspoons over to milliliters. But again, this is more about the method. So what I'm going to do is I'm going to start with where we are, right? I go 1 teaspoon over 1. I always just make a fraction out of it. And then I'm going to multiply that by my first conversion factor, which is this one. And remember, anytime we see a conversion like that, we can write it as a fraction, one of them on top of the other one. We get to choose. So what unit, I brought my sticks today because I thought that might be fun. Callie's off today. Matthew Griffin? Matthew, I'm going to use this right here. So what unit is going to be on the top? What's going to be on the bottom? So 1 tablespoon is on top, okay? And that means I'm going to put what on the bottom? 3 teaspoons. And we're doing that because we want the teaspoons to cancel, all right? So in this case, they will. Okay, now if we were to multiply across, we would be at tablespoons, wouldn't we? But we don't want tablespoons, so now let's use our next conversion factor, this one right here. And Joseph's off today. Yeah, a lot of people are. Traffic was nice, right? I said I'm going to give bonus to everybody here on the first test for being here. Leah, right? Leah. Leah?
Yeah.
Okay, Leah. It's spelled, okay, so it's not my fault.
Yeah.
Okay, thank you. Leah, I think you're good with this, right? So what unit would go on top? What unit would go on the bottom? 1 cup on top. And 16 tablespoons on the bottom. Again, because we want the tablespoons to cancel, right? And then we go again. So I think y'all get this. This one will be next. What goes on top? Ounces on top, because you want the cups to cancel. 1 cup on the bottom. And the cups will cancel. And then finally, mLs on top, 29.57353 ml over 1 ounce. There we go. Ounces will cancel. And this is the way conversion factors work. All conversion factors, whether you're going from teaspoons to milliliters or you're going from miles per hour to feet per second, it's all about trying to get units to cancel. I remember as a student, first time I ever really messed with this, maybe it was just the way it was presented, I don't know, but it just seemed very confusing. You're just using these, rewriting them as fractions however you need to use them, and getting things to go away, all right? So now it's just a matter of multiplying all the numbers together. So I break out my TI-30XS, and 1 times 1 times 8 times that. So I'm going to multiply all those together first. So I don't really need 1 times 1 times 1. So 8 times 29.57353. So the top is going to be 236.58824. That's what my calculator gave me, ml. But I still have to divide by the bottom, which is going to be 1 times 3 times 16 times 1 times 1. So really 3 times 16, right? 48? So divide that by 48. Make sense? So let's just go ahead and get that 236.58824. Final answer, 4.92892, something like that. It's about 5 ml, right? Right about 5 ml. That's it. Yes? 49, and what do you have?
Would you want us to read it as like the 4.92?
You could go 4.92. You could go 5 ml. I mean, it's a kid's medicine, right? They die, right? What, overdose, It's just a child's life, no big deal. Yeah. So yeah, on a test, it's just round. I'm more concerned about seeing this. I want to see that you know how to set it up. Okay, so 49 and 62 still, right? Let me look at 49, then we'll go back and look at 62, just to see what they look like. Wait, did I go past it? Am I in the homework right now? Was it that one? Okay, yeah, let's do this one first, then we'll do the 62. So let's see here. Come here. Yeah, this is a perfect example of what I meant by it's all about the procedure as opposed to knowing we can do this with technology pretty easily. All right, if you travel 65 miles per hour, how many feet can you travel in 22 minutes? Right? Okay, so right now, when we say 65 miles per hour, what we mean is that we go 65 miles in 1 hour, right? In 1 hour. So I'm going to divide this by 1 hour. And what we need to do is somehow get this over to what? Feet per minute, right? Feet per minute. So what I'm going to do is I'm going to ask myself, what is this in feet per minute? Right, that's what I'm going to ask myself. And this will tell me how many feet I will travel in 1 minute. Does that make sense? And then I'll have to multiply by 22 to figure out the answer, because it says how many feet will I travel in 22 minutes. Does that make sense? So first miles per hour to feet per minute. So we need a couple of conversion factors here first. We have to do two different conversions. We have to go, the distance has to be converted from miles to feet first, and then we also have to convert hours to minutes. And I think we can do this without looking up at the chart. You can refer to the chart. 1 mile is how many feet? 5,280 feet. So that's up in your chart. And then in terms of time, we know 1 hour. Oops. Pardon? I would look at the chart or just look at your life and think about how many, well, actually not a lot of people know how many seconds there are in an hour. I mean, believe it or not, a lot of people don't realize how many seconds there are. A lot of people, everyone knows there's 60 minutes in an hour, but a lot of people don't know there's 3,600 seconds in an hour. So we just use the conversion factors we know. 1 hour is 60 minutes, 1 minute is 60 seconds, right? Oh, we don't need seconds, do we? Oops. My fault. We're going to minutes, not seconds. So we don't need that last one, do we? Okay, so let's do this. We start out with 65 miles over 1 hour, and now let's call on somebody. This will be interesting to see. Melissa? No, Melissa's on vacation today. Uriel? You sent me an email, right? I didn't get to it. I'm sorry. I had a real busy week. It was my mom's 70th birthday. We had family in from out of town. I know you sent me an email, but sorry I didn't get back to you. Okay, so I'm leaving it up to you right now. What do you want to do? Like at this point, what do you want to do?
I think we have to multiply by like 5,200 feet on top.
Okay.
One mile
On the bottom. Yeah, there. So you're deciding you're going to go after the miles first. Like you'll deal with the hour afterward. Okay, and that's your choice at this point. Do you want to make the hour cancel out to minutes, or do you want to make the miles convert over to feet? And there's no order you have to go into. You just have to do them both. So first thing you're going to do, you said you're going to put 5,280 feet on top, and you're going to put 1 mile on the bottom, and you cancel the mile, right? Okay, good. So we're going to be, that'll convert us over to feet. And now, Thomas, we're over, we want to get to feet per minute. Right now, we've got the miles gone, we're at feet per hour. So you need to somehow get that hour to go away. And we want to get to minutes.
60 on top and an hour on the bottom.
Okay, so let's think about that, Thomas. If I put 60 minutes on top and 1 hour on the bottom, are my hours going to cancel? They won't, right? Because I have hours on both bottom, right? So there's no cancel. So you need this flipped, okay? So flip that over. 1 hour on top, and then 60 minutes. So what goes on top and bottom is completely dictated by where you start. So if you're trying to get rid of hours, the hour has to be on top. And that's it, right? We will be at feet per minute at this point. So let's go ahead and just multiply across. We're going to do 65 times 5,280. And then after we do that, 65 times 5,280, we will take that number and divide by what? 60. And we will get 5,720 what? Feet per, I'll do feet per minute, like that. Now realize that this is really saying 5,720 feet per 1 minute. That's what that means, all right? Feet per minute means 5,720 feet in 1 minute. Yes? Now, I think most people would realize at this point, if you want to know how far you went in 22 minutes, you just multiply by 22, right? Just multiply by 22. So take this number, and you're actually multiplying it by 22 minutes, aren't you? This is something subtle that you don't really pay attention to, but you're multiplying by 22 minutes, right? So that's why your minutes cancel, and your answer is in feet, which is the distance you went. So we take that, so times 22, and you will have gone 125,840 feet, and that is it. Does that all make sense? I like to give problems like this on tests because, you know, it forces you to know which unit's on top, which is on bottom, and you have to do multiple conversions, so. Does anybody know the speed of light? How fast light travels?
It's like 200-something thousand.
Yeah, it's 100. So the speed of light is 186,000 miles per, not hour, miles per second. Miles per second. So we don't really, like, we don't ever measure anything in miles per second, right? You don't say you're driving down the road and you're going like 6,000 miles per second, right? You're always doing it in miles per hour. So just out of curiosity, what is this in miles per hour? Maybe so we can get some idea, because 186,000 miles per hour is fast, right? But what is that in miles per hour? Let's see. So we take this 186,000 miles in 1 second, right? And I want this in miles per hour, so all you have to do is get rid of the seconds, right? So first we could go here and we have seconds go to minutes, right? We can do that. So what would we put here on top? 60? 60 seconds in 1 minute. Okay, and now we're not done because that just cancels out seconds. We're now in minutes, but we need to go to hours. So we go here now. Minutes on top, hours on the bottom. So 60 minutes in 1 hour. And the minutes cancel. So you basically are going to take 186,000 times 60 times 60. It's going to be a big number. 6, comma, oh wait, no, 6696. My comma's in the wrong place here. 0, 0, 0, 0, 0. Yeah. So what is that? Make sure I have the right number of zeros here. Yeah. So how fast is that? 669,600,000 miles per hour. I mean, that's a speed that you can't even really put your head around, can you? I mean, that's super fast. All right. Let's look at number 62. Do me a favor, if one person could sacrifice one sheet of paper, put the date on it, and let's pass it around and everyone sign in. That's what I'll give you the bonus on today, based on that, okay? Any volunteer? You got one? Okay, we've got it started back there, all right? Just make sure you get your name on that today. Anyone who missed class is going to watch this, well, if they watch it, and they're going to be all mad at me. And then the people who don't know, well, they didn't watch it, right? All right, blood makes up 7% of a body's weight. If a person weighs 175 pounds, how much would his blood weigh? Provide the answer in both pounds and kilograms. Okay. So this problem is actually two different ideas. It's two different concepts. First concept is the concept of a percentage of something. Like we've talked about what percents mean, you know, a certain percentage of the class owns iPhones, blah, blah, blah. So the first part is a percent problem, and then the second part is a conversion problem. So let me see if we have any volunteers. Here they are. Savannah? Okay, so do you know how to approach the first part of this problem? Blood makes up 7% of your weight. If a person weighs 175 pounds, how we could find how much the blood weighs? If you don't know, it's okay. Okay, so let me rephrase the question to you. What if I told you that 50% of a person's weight is their blood? Okay, so change this to a number that you're more comfortable with. Blood makes up 50% of a person's weight, all right? Now I'm going to change this to a number that makes a little more sense. What if a person weighs 100 pounds? How much does their blood weigh? Can you tell me how much that would be? 50, right? Because all you're doing is like half of the person's weight, because 50% means half. Does that make sense to everyone? So you're taking this percentage and you're doing something with this number. Now, what is that operation? Think about what I just said. 50% and 100 pounds. You said that their blood would weigh 50 pounds. So how could you use these two numbers to get 50 as an answer? Convert this over to a decimal first. 0.5, right? And then take this number and multiply the 100. And that's how you would get 50. Does that make sense? Does that make sense to everyone? How if you have a word problem and you can't make sense of it, try and use numbers that are easier to work with in your mind. That's the way it's always made sense to me. So for this problem, Savannah, you want to try it? Like how would we do this problem, 62 then? Okay, we're going to convert 7% to a decimal, so that's going to be what? 0.07. We're going to multiply that times 175. Right? And when we do that, we get 12.25 pounds. So this is person that weighs 175 pounds, 12.25 pounds of that is blood. This is average. It's not always perfect, but all right. Now, the last part says provide the answer in both pounds and kilograms. So that last part, Emily? Emily, okay. Emily, we got to go from pounds to kilograms now, right? So we just need to go to our chart and hope to see we see it there. Let's see, where's that? Pounds to kilograms, pounds to kilograms. Did I pass it? No. There it is. See it? So I'll write it down here. Here's our conversion factor. 1 pound equals 0.4536 kilograms. So Emily, what am I going to do then? I have 12.25 pounds. So what am I going to do to make that go to kilograms? We're going to use that conversion, right? So we want to cancel the pounds out. Remember I said always write this like over 1. That way you create a fraction. And then multiply it by a new fraction. So what goes on top, what goes on bottom here, Emily? Kilograms on top. So 0.4536 kg over 1 pound, right? You can go LB or LBS. I've seen it both ways. So cancel out the pounds, multiply, and we are done. 12.25 times 0.4536, and that is 5.5566 kilograms. I believe in the medical field, if I'm not mistaken, they use kilos most of the time, grams and kilos, kilograms and grams and milliliters and liters, and they do that because, well, it's easier to convert.
What system do you prefer?
Pardon?
Which system do you prefer?
I prefer that I can work in both. That's what you know what I'm saying? Like, I think a person needs to be comfortable going from one to the other. I don't care which system I'm in. Just give me the conversion factor, and I'm comfortable in both. I think it'd be great if we could get the entire country to switch over to what the rest of the world's using, but I think that'd be pretty tough to do. I don't know. Wouldn't it be nice if we all had the same system? I mean, we use the same numbers, don't we? Pretty much. So, yeah. Plus, back in when they say a foot, the measurement a foot, we know 12 inches, right? Like that used to actually be based on measurements taken from the king. So at that time back when they were using measuring systems in Europe, the king, whoever was the king, would be like, that's a foot, Or it was, it was like a measurement from here to here or something. I mean, they were measuring body parts. So if you had a different king, you had a different measurement. It's just dumb. So, all right. All right, anything else? I think we've addressed quite a few of these now. Are we ready to move on to lines? Anything else? Did I miss anyone's questions? All right, let's go on to lines. There we go. All right, so this, I don't know how familiar you are with lines. So I'm going to kind of introduce it. I know a lot of you have worked with lines, and anytime I've taught this class, students actually do really well with this part. But I'm still going to treat it like you don't remember what a line is a little bit. And I'm just going to introduce it this way. So I want you to look at this equation right now. Okay. See that equation? X plus 2y equals 6. So right now, to make that equation true, we would have to replace x and y with numbers, right? So can somebody give me an example of an x and a y that would make this equation a true statement? So give me an x and give me a y. Tell me what they would need to be to make this true.
X is 1, Y is 3.
X is 1?
Oh, wait, no.
Yeah, that's... Try again.
Y is 1, X is 4.
Y is 1, X is 4. So how about I do it this way? I'm going to write X is 4, you said, right? And then Y is 1. Do we all agree that that would work? So that's 4. That's 1. 2 times 1 is 2. So 4 plus 2 is 6, right? Okay, is that the only answer? Someone give me another X and Y.
X is 3, Y is 1.5.
X is 3, Y is 1.5. I think that'll work also. Someone else? Another one?
Y is 3, X is 0.
Okay, Y is 3, X is 0. Does that work? 0 and then 2 times 3 is 6. Yeah, that works. 2 and 2, both 2 and 2? Y'all agree with that? 2 and 2 work? Okay. Is there any way to make one of them negative? Like, could I do like x is negative 2, let's say. Could you then find me a y that would work?
4.
4? What do y'all think? Yeah, you could plug in negative 2 here, plug in 4 here. 2 times 4 is 8, but then you're adding a negative 2, so that would bring it back down to 6. So 4 would work here. And the fact of the matter is that we could do this all day long. In fact, we could do this for the rest of our lives. Just sitting here and find numbers that work. And we would never run out. There's an infinite number of answers to this. So what we want to do is see if there's a way that we can represent all of these answers visually. Right? And that's what a graph of a line is. It's a visual representation of all of the possible solutions to this equation. All right? So what we do is we write these as what we call an ordered pair. And your ordered pair is always going to look like this, x comma y in parentheses. So this written as an ordered pair would be the ordered pair 4, 1. This would be the ordered pair 3 comma 1.5. And then 0, 3. And then 2, 2. And then finally negative 2, 4. And like I said, there's an infinite number of ordered pairs, right? That would satisfy making this equation true. So then we go to the visual part. How do we represent it? We draw what we call our xy plane. So we say, okay, here's x, here's y. And what you want to do is just look at this as being a number line. Like x is a number line, and then y is a number line. We always start at 0 here, then this is 1, then this is 2, then this is 3, then this is 4, and then you go backwards on the number line, negative 1, negative 2, negative 3, negative 4, and then for the y, you go up 1, 2. I know you've seen this, okay? I'm not trying to insult you, but what I'm trying to do is explain to you why it is that when we draw this, it's a line, okay? And the reason is because we're trying to represent all these answers. And when we start plotting these as points, they all wind up lining up on a straight line. All right, so let's do that now. If we want to plot this, if we want to plot that ordered pair right there, then the x is 4, right? So we go out 1, 2, 3, here's 4. But then our y is 1, so we go up 1. And we put a dot here. And that's a visual representation of that solution to that equation. And then we do that for every single point. So I go out, next one would be go out 3, right? And then up 1.5, which would be about right there. The next one was 0, 3, here. 2, 2, 1, 2, up 2. And the last one we did was negative 2, 1, 2, 3, 4. Now, that's supposed to be a straight line, but, close enough? Is it convincing enough to you? Okay, so that means we don't have any answers over here. Like, it's not possible, which is kind of interesting. there's no way you could have, think about any number, any point, any ordered pair that would land in here. Wouldn't the x and the y both be negative? That is not possible. It is not possible. If I asked you right now, give me an x and a y that are both negative, that makes this true. You can tell by this picture that's not possible, right? Now, if I continue this, I guess what I want you to understand is when I draw the straight line, what I'm doing is I'm realizing that there are a bunch of points, right? These are all points that are all answers. But if I connect them all, I get that straight line, right? So the line is actually an infinite number of points. And that very beautiful straight line that I have there is what we call the graph of this linear equation, right? So we want to be able to graph linear equations, but we do not want to do it by just plotting a bunch of points, because this is too much work. So we have a method for graphing lines. We have two methods. We have what's called the intercept method, and then we have the slope-intercept method. So let's look at some important points on this line. I need to extend this down, and I need to extend this over like that. There are two very important points on a line. They are the point right here. That is called the y-intercept. And then we have the point where it hits right here. This is called the x-intercept. And when we go to graph a line, let me see, do you believe this statement that in order to graph a line, all you need are 2 points? Like if you give me 2 points that are, as long as they're not the same point, 2 distinct points, that there's only one line that goes through them, right? So anytime we graph a line, drawing 2 points is enough for us to be done, all right? So what we do for the first method for graphing a line, called the intercept method, is we find these 2 points. We find the y-intercept and we find the x-intercept. That's what we do. If we can find these 2 points, plot them, then we just draw a straight line and we're done. Now there's something about the x and y-intercept that is unique. And that is, if you look at the x-intercept here, on any line, the x-intercept, what must the y be here? 0. Because if you're on this line, then you don't go up or down, right? So that means your y has to be 0. And then the question becomes, well, what would this be then, right? And then on this one, the y-intercept, you can tell me because you're on the y, your x can't move either, right? So your x has to be 0. And then it's a question of what is your y? That makes sense? Kind of? Yeah. So I want us to go back to this original equation up here. And I'd like for us to graph this using this intercept method. So the intercept method is going to work like this. The first thing I'm going to do in the intercept method is I'm going to find the x-intercept. Now, you can do the y-intercept first if you want, but I'm going to do it by starting with the x-intercept. So if I want to find the x-intercept, I know that y must be 0, right? So what I'm going to do now is I'm going to set y equal to 0 and solve for x. That's the method to find the x-intercept. You set y equal to 0 and solve for x. So I'm going to take the equation. I'm going to replace this y with 0. And if you do that, what do you get? 2 times 0 is 0, right? So you get x plus 0 is 6, but you don't really need the 0, so x is 6, right? And remember I said anytime you have an x-intercept, the y must be 0. The question remains then, what is this, right? We just found what it is. For this particular line, if y is 0, then x must be 6. So your ordered pair, your point on the line is this. This is your x-intercept. Make sense? All right, now second thing is we need another point. So now we go get the y-intercept. And to do the y-intercept, it's just reverse of what we just did. Instead of replacing y with 0, we replace x with 0, and everything works out nice. So let's do that. Step 2. I'm going to do y-int from now on. I don't want to write intercept over and over. So to find the y-intercept, we set x equal to 0 and solve for what? Solve for y. So 0 plus 2y equals 6. So just replacing x with 0. And then, does it make, I don't know, maybe you already knew to do this. Like to find the intersect, x-intercept, you set y to 0. Find the y, you set x equals 0. Maybe you already knew that walking in here. Maybe the picture hopefully helps you see why we do that. X-intercept, the y has to be 0. Y-intercept, the x has to be 0. So what does this turn out to be? Y is 3, right? We get 2y equals 6. We divide both sides by 2, and we get y equals 3. And now we write that as an ordered pair. And the ordered pair will be what? This is 0, right? This is 0, and then this is 3. Because remember, we set x to 0, right? So that's why that's like that. We had set y to 0, which is why that's 0 there. All right, and that's our y-intercept. And once we have those 2 points, we draw a graph, plot the 2 points, draw a straight line. We're done. So my third step would be to sketch it. And I'm going to do that, even though we've already done it. Third step, plot points, plot the intercepts, and then draw a straight line. So this doesn't have to be like the most perfect graph in the world. I would just say my x-intercept is 6, 0, 1, 2, 3, 4, 5, 6. Here we go. I draw a dot. And then 1, 2, 3. There's 0, 3. Draw a straight line. And I'm done. All right. We good? Let's do a different one. All right. Just out of curiosity, what if I change this x to x squared? Can we do the same thing and draw a straight line? No, this is no longer a line. All right? This happens to be what we call a parabola. But the important thing about graphing lines is that you have to understand that what you're looking at is a line. So what is it that makes this a line? This x is to the first power, this y is to the first power, and there's an equal sign in there. That's what makes it a line. As long as you have x and y, they're both to the first power, and you've got an equal sign there, you are looking at a line. All right, the equation of a line. All right, let's do another one. Negative 2x minus 3, or make it plus 3y, equals 12. So is this a line? Yeah, you have x to the first power, y to the first power, and equal sign in there. Andres, there you go. X-intercepts first. So, sure, x-intercept. So how do I find the x-intercept? Make the y 0. So I'm going to set y equal to 0, and now let's see what we get. Negative 2x times, setting y to 0, right? Yeah. 3 times 0, right, equals 12. Oh, you were giving me the answer. I'm sorry. I thought you said 2x minus 6. You were just giving me the answer. Okay, so this is going to be negative 2x equals 12. So the 3 times 0 goes away. Divide by negative 2, and you get x is negative 6. So what is this as a point, Andres? Negative 6, comma 0. Just make sure you get that order. They call them ordered pairs because the order matters, okay? All right, let's see. Hayden? Is Hayden here today? No Hayden? No? Colby? Robert? How you doing, Robert? You get the y-intercept. So how do I do that, Robert? X to 0, okay. And when I set x to 0, what equation do I get, Robert? I like your name. Set x to 0. Okay, negative 2 times 0 plus 3y is 12, right? So this is going to go away. That's gone. So you're left with 3y equals 12. What do I do now, Robert? Divide by 3. And 12 divided by 3 is 4. So, Robert, as an ordered pair, what is it? 0, 4. Okay? There we go. Here we go. Pick one, pick one, pick one. Tatiana?
We've already found the X and the Y intercept.
Yeah, so what do you do now?
So I was thinking that we could combine it together, so like negative 6 for the X and the 4 for the Y.
How do you mean, combine them? What is our third step for the intercept method? What is our third step? What did we do in the previous problem on our third step?
Well, at first we can do it for the angles of for the intercept chart.
Yeah, go in here, right? Just go to the graph and put them on here.
Right.
So let's do this first one. If I do this first one, where's this one on this thing?
For the X
So I'm going to start here. You tell me where to go.
on the left,
Left? How many places?
6.
Right there. Everyone good with that? And then next one?
Let's go up to 4.
Up 4. 1, 2, 3, 4. There you go. And then just straight line, you're done. Okay, good. All right. The intercept method is pretty straightforward. Would you agree? There's not a lot of craziness to it. Now, what makes it get crazy is when your equation starts to have things like this in it. So let's do another one. 1/4 x minus 3y equals 1. Okay, that is still a line, isn't it? I mean, there's nothing that makes that not be a line. But now you've got some fractions in there, don't you? And so you don't like the fractions, and I get that. Skylar? Skylar? No? Anna? Liliana? There you go. All right, so if we're going to do the intercept method, right, the first thing you do is go get the X intercepts. Then you go get the Y intercepts, and then you plot your 2 points and draw a line, right? That's the method. But you got to work with the fractions now. Okay, so let's start this out. First step, X intercept. So what am I going to do? Set what to 0? The Y, right? So Y goes to 0. If I rewrite the equation, Liliana, what do I get? So remember, this is gone, right? This is going to get killed off. So all you're left with is what? 1/4 x equals 1. Okay, good. Now, how do we get rid of a fraction in front of the x? There's kind of two ways to look at this. You can divide by 1/4, but that gets complicated and students tend to mess that up. Liliana, are you comfortable with the way to get x by itself and get rid of the 1/4? Okay, anyone else have an idea? Multiply by the reciprocal of the fraction. So you see this fraction here is 1/4? If I multiply both sides by this fraction flipped over, then it will kill off this fraction. So I can multiply both sides by 4/1, which is really 4, isn't it? And that means I'm multiplying this side by 4. You don't have to write 4/1 on the other side. Does that make sense, Liliana? These 4s will cancel, the 1s will cancel, all you'll be left with is the x, and then on this side, 1 times 4 is 4. And so, Liliana, what is the point? What is the ordered pair that I have here? 4, then 0. All right. Now the y-intercept is going to go a little easier because we set x to 0. If we put x and 0 here, look, it's going to kill that off, won't it? And so all you get is negative 3y equals 1. And now for this, because negative 3 is a nice whole number, we'll just divide both sides by negative 3. So divide by negative 3, divide by negative 3. These are gone. You get y equals 1 over negative 3, right? That's what it is. And now you can look at this fraction, and we talked about this in class before. You can just look at that as being negative 1/3. That negative on the bottom can go out front or on top. I'm going to just put it out front, negative 1/3. Cameron? Is Cameron here?
Yes.
Hey, Cameron. What is this as an ordered pair?
0, negative 1.
0, negative 1/3. Okay, Cameron, I'm going to draw this for you. And okay, so Cameron, how do I get to that first one over there?
Go right by 1/3.
But this, let's do that one right there.
Oh, the first one?
Yep.
Sorry.
So where is 4, 0?
Up.
Up. What's your x coordinate there?
Sorry, over the word. I'm sorry.
It's all right. It's Monday, and we shouldn't even be here to begin with. So, yeah, like that. And now this one is the one I'm curious. Like, what am I going to do here? Down 1/3, right? So, like, where's 1/3? Yeah. Well, this is 1, right? Negative 1. And like that's like halfway, so not quite. So you're just going to eyeball this, right? Just going to eyeball that, and then you're going to draw your line. So on your test, what I'm less concerned about the picture, like you having that perfect. What I'm more interested in is you getting these x-intercepts and y-intercepts written correctly, and then go and try and plot them. If you have all this information right, and your picture looks pretty darn good, then we're happy. Okay? All right. How about this? Let's see here. How about this one? So I said that a line, you have to have x and y to the first power with an equal sign, right? That's what I said? And so someone might say, well, hey, there's no y in there, right? I agree, I don't see a y, but just bear with me for a second. Isn't this the same as that? I mean, I know it's not that, but isn't that the same thing? It's like you have no y's there, right? Like 0 y's. So this can still be looked at as a line. And this is confusing for students, like that's actually a line. All right, but let's think about it. If I asked you right now to give me an example, like we did in the very beginning, give me an example of an ordered pair that would satisfy this equation, then what is one example of an ordered pair you could give me here? Negative 2, 5. Okay, because negative 2 is x. That's true, right? Negative 2 is negative 2. And then the 5 has no impact, does it? Because there's no y in here, right? And then you give me another one. Negative 2, 4. Negative 2, negative 5. Negative 2, 0. And you could go all day long, couldn't you? As long as you keep the x negative 2, the y doesn't matter, does it? And so whenever you see an equation like this, where you only have one of the two variables, you have a very special line. So you don't go and do the intercept method for something like this. You just go directly to the graph. Now, if I just pick any of those 2 points, any two, that's all I need, and I'm going to draw a straight line. So the important thing is that your x is negative 2, right? So I could go negative 2, 5 was up here. I could go negative 2, 4 was right below it. Negative 2, any of these, right? So I wind up getting, what type of line is this? This is a vertical line. So whenever you see x equals a number, okay, that's a number. X equals a number, you're looking at a vertical line. The way that I remember it is vertical lines, right? All the x values are the same. Your left and right is x. They're all the same in a vertical line. And this is telling you x has to be staying at negative 2 the whole time. Now, how does that compare to this problem? y equals 3. Same thing, but now your y coordinate has to stay fixed. Your y coordinate is up and down, right? So if your up and down has to not move, then it can be any point that lies along a horizontal line. So some examples of answers here: 0, 3, 2, 3, 5, 3. Again, you could do this all day long. Just graph any two of those and you're done. So I just go up 1, 2, 3 here, put a dot, go out 2, go up 3, horizontal line through it. Are we good? Make sense? X equals a number, vertical line. Y equals a number, horizontal line. If you have X's and Y's mixed together, then you're not, so if you, the previous problems we did, we had X's and Y's at the same time, didn't we? Anytime you have that, you're guaranteed that your line is not going to be vertical or horizontal. It's got to be something in between if it's not one of these two. Okay, let's take a look real quick at the lecture notes. So for these problems, we're not going to do these right now. I just want us to look at them. You're supposed to use the intercept method. So for these, you know, to do this one, you find the x-intercept, you set y to 0, right? Find the y-intercept, set x to 0, get your 2 points, and draw a line. So that, we've done something like that. Does it bother you that the x's and y's are on different sides? Are you okay with that? It's the same story. You're just going to replace one of them with 0 and solve. These all appear to be pretty much the same that we've done. Okay, so what about this one? Can you tell me what kind of line that is? You only have y, right? How would I get y by itself here? Multiply by the reciprocal. So I multiply 2 over 5 here, 2 over 5 here. But it's y equals a number. And there's no x in there. So that's a horizontal line. What about that one? Only x, right? So this is a vertical line. So you divide both sides by 8, you get x is negative 2. That's your vertical line. Okay, so now the other method is called the, wait a minute, hold on, no, this is the same thing. Sorry, same thing. So this is just, on these problems, they just wanted you to find the x and y intercept. They didn't want the graph. So you just find the 2 points. Here, they want you to actually draw the graph, which we want to. Ooh, how about that one? Yeah, let's do that one. All right, so that just looks kind of ugly, doesn't it? First step, find the x-intercept. And to do that, we let y be 0. And Adriana, if I let y be 0, what's my equation going to be? Negative 1 over 8x equals a half?
Yes.
Okay, so good. You kept that negative sign there, so that's something to be careful with there. You're replacing y with 0, kills off this one, but you still have the negative there. So negative 1/8 x equals a half. Now how are you going to get x by itself there? So you have a negative 1/8 over there, right? So what I say, if you have a fraction, you want to get rid of it, multiply by it flipped. Yeah, so what is that fraction flipped over going to be?
8 over 1.
8 over 1. Now what about the negative? Yeah, we're going to go negative 8 over 1. And why do we do negative 8 over 1? Because negative times negative is positive, and that will leave us with a positive x over here. So I'm doing negative 8 over 1 over here, and then whatever I do to that side, I have to do to this side, negative 8 over 1. Does everyone follow that?